Great. Oh, thank you. Thank you for that presentation. Super to have you all here. I see it's a really big crowd, so we're gonna make a really good webinar of this, and I hope that will be a lot of questions going forward later on. Of course, then we go. This theme today in the webinar will be how we see how we can develop ECUs better in a new and simplified way, and also reduce the complexity within the ECU projects. And this is the agenda, a brief one. Of course, we will go through why we are here today. Of course, the automotive industry have some challenges today. We will also go through the role of a bootloader in a project, and also how we work to simplify, secure, and accelerate ECU projects. And of course, a summary and then a short Q&A sessions. So, our customers then, they are facing 5 main topics today. They are facing challenges in the electrification of their vehicles. You know, AD and ADAS have been a big topic for many years, but are not there yet. We're also facing software maintenance and update issues, over-the-air updates. We are facing traceability issues with software, but also time to market delays. Several OEMs have big delays for several years for the new models, but also a business that struggles with the aftermarket and how to make money of it. So, as our European industry is today facing a big dilemma. It's been one of the biggest players within the passenger cars. However, in the recent days, we can see on the right-hand side here, the sales of battery electric vehicles. There are new entries, and also from the Tesla side, but also on the Eastern Asia side, taking 51% of the combined market as today, as our traditional OEMs in Europe have only 20% of the market. This is a big issue, of course. Then the McKinsey, the management firm, say there will be several main factors how we should gain up to the speed of the new players. We at the Diadrom then, we are focusing on closing the software skill gap within the automotive industry with both processes, education, and experts, and also different tools, etc. This also gives us a focus for helping our customers to reduce cost, but also accelerate speed in their development of new platforms. The main big paradigm shift in the industry is going from a decentralized electric architecture into a centralized one, which many calls the software-defined vehicles fundamental, where we go from small ECUs to bigger high-performance computing units. That will be a lot of software going on, a lot of communication, and this will increase complexity for the OEMs. Of course, the enablers are one of the big thing is upgradability. We need to upgrade the car throughout its lifetime with new features, but also new software. And this creates also a big maintenance of the software, etc. And when we create the bigger ECUs and high-performance computer, there will be a lot of players moving into this area and have to combine and have to share the same microcontrol unit, and it creates also complexity. I think the main thing we have to work with is scalability. We have to reuse our software throughout several platforms to gain cost and speed improvements. Yes, as you all know, in the aftermarket business, you have to take a car into the repair shop and you have to change the oil filter, and that's one of the biggest margin products out there for the OEMs today, oil filters. How many oil filters is in electric cars? None. So we have to find out how we should make more money, And this is a slide from Mercedes-Benz, who will implement functions over the air, which they will have a subscription on. And for example, seat heating will be $120 every year. Main trend also, we have the vehicle cybersecurity. As we open up our cars to more connected services, we open up to more possible threats and entries to our cars, but also like physical stuff, the traditional ones, the OBD, USB, etc., but also facing you Wi-Fi, mobile, etc., where we can be attacked. And of course, the main big issue is, as we can see, or the result of all these things are delays and impacts on software-defined vehicles. We have some major OEMs whose platform is delayed, and this mainly because of the software getting more complex. So in short, we face growing complexity in the industry. We need to accelerate time to market, but we also have to care of our human resources, educate them accordingly, and also have to reduce cost by reusing software or tools, etc., to meet our new competitors. So one main big thing is, of course, we need to update the software. And what's the biggest enabler of that? The bootloader. We are going to go through what is a bootloader and the 6 sections here: the vital role, flexibility and updates, security, diagnostic and recovery, also optimization, and why it's a strategic asset in ECU development. First of all, in today's fast evolving automotive industry, the software have become increasingly sophisticated, and we have to rely on the software a lot more than we had previously. Then in these complex systems, we have an overlooked component, the bootloader. The bootloader gives us flexibility, but also security, diagnostics, and also is a fundamental of the ECU software for managing hardware setup, startup times, and software loading. Yes, it also gives us the flexibility updates. It's enable safe, efficient software updates, both physical but also remotely. We need to start do over-the-air features updates, for example. Then we need to handle these software updates via bootloader. And also it gives us the enabler of updating new feature and applications, which I talked with before. We need to make more money, then we have to give our end customers more functions which they are able to subscribe or buy in the future. Security, as I said before, the bootloader may be the first line of defense against cyber threats. This is where we upload new firmware, for example, and this we need to be very concerned about. We also need to look into new setup how to authenticate software, which will protect the whole ECU and the whole network. Yes, diagnostic and recovery. Yes, of course. Sometimes things go wrong, software update, etc., will be interrupted, and then we have a backup for this, so we don't brick an ECU, and we have to take the whole ECU, just throw it away, but we can do a new software update via the memory. And then is the optimization. Of course, we need to have control over the software loading and the execution process. We have to enhance more performance, etc., and improve the overall user experience. But also a main thing, of course, if you look into the main costs related to ECUs these days are, of course, the electrical bill of material. If we can choose a lower end microcontroller unit, for an example, then we're able to decrease the price of the ECU even more. So this is why bootloader is a strategic asset in ECU development. We needed to simplify and secure the ECU, of course, and also turns like complex challenges into streamlined, efficient processes. Great. Then we are all set what a bootloader is all about then. Now we are going into some lessons learned and how we work to reduce complexity in our ECU projects. And of course, the role of the bootloader within an ECU project is to increase the ECU for managing, for example, new feature function, etc. As a digital shift in the automotive industry. We are also going for more connected vehicles, which underscores the importance of ECU bootloader updates, but also a new feature as remote over-the-air updates will also be simplifying maintenance because you don't have to be next to the hardware. And of course, traditional firmware update will be really efficient and really costly. So how do we do when we are working with the bootloader development? We are, of course, working according to a modular software architecture. We are breaking down the different components. And why are we doing that? Because it creates flexibility, but also scalability. We are going from a Renaissance microcontroller one day to a microchip controller next day and have the same result every time. We are working a lot of with automated testing because it's ensuring quality and efficiency throughout the process, of course. If we're testing all the time, we will have the same feedback loop and we can improve it as we go. And of course, continuous integration. We are a lot of players within an ECU, and if we could streamline it into one CI chain, then we will have faster and more reliable deliveries to our customers. So, as I said before, cybersecurity will be even more important in the future. We, at our project, cybersecurity are at core. We indeed start with cybersecurity and we almost end with cybersecurity as well. Why? Because we have to be maintaining this software for over 15 years, and we have to create this so people are not able to attack ECU or network. How do we do that? Today we are using advanced encryption for protecting from unauthorized access and tampering. One thing we're working a real lot with is high security modules or HMs, which have an ongoing cryptography library, which we are able to do secure boots via, for example. And of course, the new assessments regarding cybersecurity, the 21434 and the UN directives will be crucial to work with. So, our strategies to reduce time to market. We use agile methods. We need to shorten the cycles. We have to have faster feedbacks throughout the project. We have to work really close with the application team, so they are having the functions they need to start their project. Also, we need to do simulations of the software and also and the application side. And we also have to reduce the legacy and the dependence on hardware bottlenecks. So simulation is a really core in this as well. We have to do cross-functional teams and also increase the transparency. We have enhanced the collaboration between software, security, and hardware experts, both on the supply side and on the customer side. Elevating quality and efficient in ECU projects as well. We are working with quality by design. We're working hard with the ASPICE regulation, but also the ISO 9001. This create a traceability for our customers and ourselves, how we've been developing software. And also we try to allocate the right people at the right time for improving the maximum productivity. And also feedback loops is really important when we're going into this. So our key takeaways for this webinar and our projects is we need to help each other to close the gap of software complexity. How we do that then? We need to develop tools that are doing just one thing or one thing really good. We have to implement the right process from the beginning, of course. The second one is, of course, to reuse and reuse and reuse both software test and verification method. If we do that, we get high quality, we got a faster time to market, and that's super important. And of course, we have to have niche players that focus on the customer value. The tier 1 suppliers should focus on them, and tier 2 suppliers will focus on the tier 1's value. And this, we need to create partnership throughout the ecosystem. And of course, we at the Diadrom, we have tools for this, and we also have products, as you can see, and we also have some good partners like Foster in our ecosystem. And that's a really great asset as we're going forward. So what have we learned today? We have talked about the pain points of the automotive industry and how we could reduce them. We have talked about the role of the bootloader. What is a bootloader and what can you do? And we also have talked about simplify, secure, and accelerate processes in our ECU projects. So great. Let's see if we have some questions, and thank you for all for hanging out until our questions. Super. Welcome, Joachim.
Thank you, Viktor, for a nice presentation. We have some questions, and please write questions in the chat if you come up with any question. But I will start here and look into the chat. SDV, software defined vehicle, is the automotive buzzword of the year. Yes, we know that, everyone that attended CES, but what is SDV from a diagnostic perspective?
Yes, of course. Great question. The software-defined vehicle, I think that's, as we said here before, it's a great challenge for everyone in the software domain, of course. From our side, it's almost like business as usual. Our expertise will be probably the same, and our solutions, of course. But the main challenge we have today is, of course, how should we all play in like the high performance computing units, and I think that would be quite crowded. And there we have to have some concept which kind of features and applications should go into the car, and you cannot have everything, and that's why we call user defined vehicles. Yes. Maybe so the user, of course, is always
and I think it can create great opportunities for us, all of us working in the software industry, especially in the automotive industry.
Yes.
And we have another question here. Can the diagnostic expertise and knowledge from the automotive industry be used in other industries? Interesting question.
Yeah, super. That's super interesting. Yeah, of course, as automotive industry is a few years in front of everyone else, I think there are really big gains of looking into the automotive industry, how we work with the business models, the software updates for the feature growth, etc., to create a bigger business, really. So I think it's a good point to look into this if you are like a moan lawer or something.
Yes. But can you give an example how it can used and how other companies working with software capital products? What can they learn from the automotive industry? But because everyone talks about that automotive industry is ahead of other industries, regarding using the possibilities with the software.
Correct. As I said before, of course, business model would be a great thing, but also the cybersecurity stuff, I think, will be a big thing for IoT stuff. So
you say cybersecurity? Never heard about that.
No, correct. But that's a thing you should put into your memory.
Okay. But you were talking about, when I listened to you, that bootloaders are the first line of defense. Can you explore that a little bit?
Of course, as we said before here in the presentation, we have the first attack surface might be to replace the firmware, etc. So that's one of the main things I think we should go into. Yeah.
But have you faced any, because cybersecurity is a tricky thing, have you faced any obstacle during implementation of cybersecurity?
Yes, we have faced a lot of it. I think my colleague David is here as well. Have we faced any big issues regarding?
So you have a lifeline?
Yes, I have a lifeline. Yes, correct.
Yeah. When we started with cybersecurity, was it 2018? There was they just started with cybersecurity, at least for our customers, and there was a lot of obstacles, but mainly there are the computation time for cybersecurity stuff takes a lot longer time than you usually think of. You think of, okay, we can put it on an external hardware device and it will boot up and everything will be fine. But every single thing of the cybersecurity add up to the computation time. So yeah, so that's one of the obstacles. You need to also adapt to it to the requirements and stuff like that to the new cybersecurity, and that's one of the major obstacles that I find when we're working with cybersecurity.
Yes, super, great, thanks, David.
We have another question that came in a couple of minutes ago, and maybe also a part of that question, and that is, does the bootloader become a subscription that our customer can use?
As this is something at the core, so no, I think there will be not some kind of. We are looking into if you can subscribe to some kind of portal which you can handle different MCU, etc. But that's for a tier 1 supplier or an OEM, but not an end customer.
Okay, so you are not the CEO of a startup company then?
No, not as today, but hopefully in the future.
Yes, yeah. I think I can see that one person is writing here. See if the question is popping up in the.
I think it's Roland. Yes.
How to handle safe fallback and have the traceability in case OTA download or new software update fails. Any suggestions how to handle?
Super question. I think actually we've looked into this recently, and I would like to pass it over to David as well. David, if you have a few comments regarding that.
Yeah, I think that's the biggest issue regarding OTA, how you handle it. But as when we have looked into it, it seems the best way is to have the A/B swap. Some CPUs or manufacturers have it implemented in their cybersecurity module, and then you just pretty much you have 2 banks in the memory block, and the CPU or the hardware provider just do the swap, and if it fails, it will automatically go back to the failed one, and you can have it in the bootloader as well.
Nice.
Okay.
Maybe Roland has a further question, or he's writing now, but maybe we should.
We can take one more question.
Yeah, but if you only have one bank for the application, it will be tough.
Yes.
You need to have a secure bootloader that you can always verify the application. I wouldn't really recommend to have an OTA for the bootloader. You have to have it the bootloader needs to be good in the beginning, if you say like that.
Yes.
Mm.
Great. We need to get back on you on that, Roland, I think. Thanks, David. Yeah, great. Thank you.
Yes.
We need to talk soon, Roland.
Yes, and we are going to share more knowledge and inspiration about software, diagnostics, and autotech by emailing our diagnostic book and white papers to you, so you can download them if you want. You can also subscribe to our newsletter, and all that will be in an email with the presentation and the recording. Additional suggestion, if you want to update your knowledge and inspiration about the things we have been talking about today, software, diagnostics, and autotech, is to follow Viktor Eliasson and the Diadrom at LinkedIn. Viktor is writing a lot of interesting things for us nerds that are interesting in this kind of
Trying to keep up.
Yeah. Trying to
be in forefront. Yeah. Trying.
Yes.
Super.
And
no,
wrong again.
More questions.
No more questions. But we want to thank you all.
Great. Thank you.
And have a very nice weekend. And we hope the sun shines on you too.
Yes.
Thank you.
Thank you. All the best.